a look at the components of standard form, and then how do we switch it to something that we can put into vertex form. What's it going to take to do that? First thing you need to do is visit perfect square trinomials. If you're not very familiar with them, there's binomial squares and PSTs are both math shorts on the YouTube website. I would spend some time being familiar with them. If you can't recognize PSTs, we're in trouble. Actually, we're not in trouble. You're in trouble. How do you tell if there is a PST? Standard form, if half of b squared is equal to a times c, then you have a perfect square trinomial. You should know perfect square trinomials for factors. And the way you tell if it's factorable by a PST is if this is true. If it's not true, then you move on and you do borrowing from the clouds or diamond or box or something like that. So this is if I give you a trinomial, if this is true, it's a perfect square trinomial.
So the first thing we should do is keep track.
No, I mean, it depends on the problem. This is something you're supposed to come to me already knowing. I know that 90% of you couldn't identify a perfect square trinomial if your life depended on it. I'm teaching it to you now. You'll see where it fits in today's lesson in a few minutes. This is how you make or tell if you have a PST. The other way is you could take the square root of a times c, or better yet, root a times root c. If that's equal to half of b, then you have a perfect square trinomial. These three things right here are all doing the same thing. But you want to be able to recognize those. And I'll show you some examples here of this in a minute. But like I said, back in August, I asked you to go figure this stuff out so that when you got here, you wouldn't have to learn something you're supposed to already know. One more thing to the pile makes the pile in Chapter 4 insurmountable. If you have a PST, then factoring is easy. You take the square root of the first term, ax squared. You take whatever the first sign is here. If it's a plus or a minus, put it right here. And then you take the square root of c, wrap it in parentheses, and square it, and you'll have a factored trinomial. It becomes a binomial square. It's the square root of the first term, whatever the first sign is, the square root of the last term, wrapped and squared. Now, because you're not familiar with these, some of you may be thinking, well, what about bx? What happened to the b? It's gone. Remember, this is a binomial square. We've talked about this over and over again. I've never had a class that knows how to square a binomial before. Everyone in the room. It's never happened. I hope you guys are going to be it. When you have a binomial square, you square the first, you double the product, you square the last, and that's what gives you your trinomial. So when you double the product, that's where b comes back into play. A perfect square trinomial always factors to a binomial squared.
Yeah. When it says ax, like ax radical over radical,
ax radical over. Got to be able to talk the talk.
The first factors to what that equation.
What is this symbol? How do you read that symbol? Square root.
Square root of ax squared.
Yes.
Why is there like a power 2?
Because that's how this factors.
So, but when you're like square rooting those two, isn't that canceling out
Let's take a timeout right here and let's make sure you've got it, and then let's look at some examples and see how it works.
All right.
Okay. Everybody okay with this page? Again, this is something I asked you to do back August 12th. Excuse me? Is this really what we want to talk about? Do you understand what I mean when I say this? This should have been done a long time ago. Okay? So here's an example. Now I've chosen this. This is as simple a perfect square trinomial as you can get. What's A? 1. What's B? 4. What's C? 4. A, B, C. Half of B is 2. 2 squared is 4. A times C is also 4. That's a perfect square trinomial. The square root of A is 1. The square root of C is 2. 1 times 2 is half of B. It's a perfect square trinomial. If it's a perfect square trinomial, you take the square root of the first term, x squared. What's the square root of x squared? X. The first sign goes right here. The square root of the last term is 2. That goes here. Wrap it and square it. This is a binomial squared. That's how PSTs factor. How do you know? 9 words. When you square the first, you get x squared. When you multiply these two together, what do you get? 2x. When you twice that product, you get the middle term. Square the last. 4. A binomial squared, you square with 9 words. If 9 words is too many, skip the thus. But you need to be able to do this. Square the first, twice the product. Square the last. There's a GBHS math short. It would take you 5 minutes to learn how to do this stuff. But you have to do it. Otherwise, you're going to be in a position where you're going to constantly not know what you're doing. And as I said at the beginning of chapter 4, this is the beginning of the blow-up for a few of you. All you have to do to avoid it is study. And I think some of you are hearing, all you have to do is avoid studying. I can do that. The square root of A is the square root of C. 6 times 5 is that half a C or half a B? Yeah. 30 is half of 60. Don't worry about the sign. It's not important. The square root of the first term. 6y. The first sign. Square root of the last term. Wrap it. Square it. You've just factored it. However, you can only do it if it's a PST. How do you know if it's a PST? Square root of A times square root of C has to equal half of B, which it does. Or you could take half of B, which is 30, and square it, you get 900. 36 times 25, also 900. The numbers just start getting bigger, so it's easier to do it the other way. Question? Square root of A? 7. Square root of C? 3. 7 times 3? 21. Is equal to 21, so it's a perfect square trinomial. No. It has to be half of it. This is not a PST. So how do you factor it? Well, hopefully you do. Yeah, whatever method you're going to use. 49 times 9, put it in a circle, borrow from the clouds, whatever. Maybe it's not factorable. I don't know. But I know it's not a PST. But I do know that some of you will still say it's 7x plus 3 squared. because this is a perfect square and this is a perfect square, it must be a PST. No way. AX squared plus BX plus C. Some basic things before you even maybe try the square root and square root. First of all, if C is not positive, it can't be a PST. Hi.
Hi. What do you want these?
You just put them on that table. Thanks. If C is negative, it can't be a PST. A and C have to be perfect squares. So if A or C is not a perfect square, then it can't be a PST. And there's no way that you can have a PST if B is off. So, you know, I'm not saying at a conscious level you have to look at all of these things. They just have to be true. If A is not a perfect square, or C is not a perfect square, or B is not even, like this, B is not even, there's no way that can be a PST. Perfect square, positive, but odd in the middle? No way. Now we're going to talk about solving the equation. X squared minus 8x plus 16 equals 25. We have a variety of ways to do this. Okay? X squared minus 8x plus 16 equals 25. Look at this trinomial. That trinomial is a PST. How does it factor? Boy, it's x minus 4, round it, square it.
So x minus 4 equals 5?
Nope. That's just how you factor it. You're responding without thinking it all the way through. If you can recognize this as a PST, that's fantastic. It might make solving easier. How do I solve now? What do I do next? The square root. On the left, it's easy. But if this is what you do on the left, what do you have to do on the right? Plus or minus. You can't just put 5. It's got to be plus or minus. Otherwise, you need absolute values over here, which is royal pain. So to solve, you get 4 plus or minus 5. What does x equal? 9 or negative 1. Should I put parentheses around that?
No.
Why? There's 2 of them with a comma.
It's not.
They're both x's. They're not y's, and there's no y's in this problem at all. How do you know if you did it right? Plug them in. Plug in a 9, you get 81 minus 72. 81 minus 72 is 9. 9 and 16 is 25. Negative 1 squared is 1. Plus 8 is 9. Plus 16 is 25. Those both check. Very few people check. In this class, more will check. We'll have maybe 10 of you will check. And you can check in your head. I don't care. Bless you. But check. Now, are there other ways to solve this? Sure. Subtract 25 and factor. Works great too. Works perfect. Today's lesson really is about completing the square. And completing the square is a step-by-step process. So what you want is to be able to turn a trinomial that is not a perfect square trinomial into a perfect square trinomial. Okay? X squared plus 6x plus 9 becomes x plus 3 squared when it's factored. We want to be able to get the binomial squared out of this so that we can get to vertex form or parabolic form. This process is lots of steps. Okay? Some of you are going to get so caught up in, I have to write down all these steps, that you're going to miss the lesson. I would encourage you to get the notes for these steps online tonight and not copy them down during class. I would copy down the examples, look at the examples, try to go through the steps with me. But I wouldn't spend the next 10 minutes copying and not paying attention, because they're online. This slide is online. All you have to do is print it, or copy it once you print it. This is the process for completing the square. The process is one of those things where so this process for completing the square starts with an equation. And you want it in standard form, set equal to 0 on one side. These are my notes. I'm not going to argue with someone who says, oh no, you shouldn't have it. It should have 14 should be over on this side. I'm not arguing with you. This is what I do. Do whatever you want, but this works. So we start in standard form equal to 0. That's number 1 here. So the numbers in the circle correspond to the steps over here. Step number 2 for me, when I typed these up, was to put C on the other side. So I start equal to 0, then I bump the C over. So I subtracted 14 in this one. Step number 3 is really important. To make A equal to 1, you divide both sides by A. Sometimes A will already be a 1, but in this case it's not. So I divided everybody on both sides by 2. Sometimes you end up with a fraction, and you'll need to practice some of those. Right? So we end up with x squared plus 4x. So the x squared plus 4x, I tell, and I still do this, put plus blank on each side. So right here, after the 4x, I put a plus blank, and right here, I put a plus blank. Then, here's the key. Take half of b, whatever b is 4, take half of b and put it in a circle off to the left here. And I put a plus or a minus, whatever sign goes with it. Put that there, because that number in the circle is going to be really important when we factor the left-hand side. So take half of whatever b is. It's a plus 4, we put a plus 2 in the circle. Then square that number in the circle. So the number in the circle is plus 2. It doesn't matter whether it's plus or minus, it's going to become a positive. And put that number in the blank on each side. That's why I put a blank on both sides. Remember, you're going to add 4 to the left, add 4 to the right. So we squared the number in the circle and put that number in the blanks. Factor the left side. I promise you, if you've done it correctly, the left side will factor into the variable x, the number in the circle, wrap it, and square it. This right here in yellow is going to be a PST. You know how I know that? Because I made it a PST. That's what we mean by completing the square. When we took half of b and squared it and put that in the C spot, we created a perfect square trinomial, and you always will.
Who was the first person who came up with this?
That was Max von Lampard. He was a German 8th grade student back in the early 1600s. And Max was pretty lazy. Yeah, and so he came up with this process for completing the square. What do you think? Believable? It came up pretty credible.
Good piece of tape.
Yeah? But not believable? I have no idea who did that. Somebody came up with it. Some mathematician.
You really wanted to go through all this work?
Yeah, because you're going to have questions that say, put this into vertex form, put it into parabolic form, and you have to be able to do that. Okay? So there's a value to it. I'm not saying you're always going to want to do that, but sometimes you're going to be asked to put it into parabolic form. Okay? And that gets you into our form with H and K, or C, D, A, and B, so you can get vertical stretch, translation vectors, instantaneous, and then if there is a horizontal stretch factor, it would appear. Kurt, do you have a question? Or?
No, because it's like I don't.
Okay, so we factored the left, and we got the x plus 2 squared, and on the right, you just combine your two numbers that are here, and we got -3. Now, we're back to what we did a few minutes ago when we're just going to solve this equation. How do we solve this? We square root both sides, so x plus 2 equals plus or minus the square root of -3. Don't forget the plus or minus. -3 under a radical becomes the square root of 3 times I. We subtract 2, and we get -2 plus or minus I root 3. Or if you want the I after the radical, just make sure it's not underneath the radical. I'm flexible either way with that, but if it looks to me at all, if the I looks like it's with the 3, that's where I'll mark you down. So you've got to be very meticulous about that. This process, you can see it's 8 steps the way I wrote it. If you read the steps to yourself 3, 4, 5 times, you'll have the process down. If you try to fake your way through it and not learn it, it will show at the end of this chapter. Any questions on this example before we look at some others? It's about organization and being meticulous. Okay, let's try another one. Now I'm going to take you through the steps. I'll say the steps out loud for you. Step number 1 is to put this in standard form equal to 0, and it's already there. Step number 2 is to get rid of the 150. Notice how I leave a little space between the 36x and the equals. I do that because I know that I'm going to be putting a plus blank here eventually. I'm not doing it now, but I'm kind of getting ready to leave room for that. Okay. The next step says to get A to equal 1. So we divide everybody by 3. So that's my x squared minus 12x is equal to -50. Did I make a mistake? And then we put plus blank on each side. And we take half of b. What's half of b? 6. But we really want it to be -6. Put it in the circle off to the left. What do we do with that number in the circle?
Square it.
Square it. Then put the result in the blanks. So we square the number in the circle and put that result in each of the blanks. On the left-hand side, what do we now have? I know what it says. What is it? EST.
So why did you make that -6?
Half of b goes in a circle to the left. So if you look back here, take half of b and put it in a circle to the left. That's the number that went right here. So in this problem, half of -12 is -6. Take that number and square it. What do you get? That goes in each blank. When you square it and put it in the blanks, the left side becomes EST. The beautiful thing about this, it will always factor to the variable, the number in the circle, wrap it, and square it. And then on the other side, in this case, we get -. And now you just finish off the solving by square root. So x minus 6 equals plus or minus I root 14, or square root of -14 if you want, and then add 6. Get your 2 solutions, both of which are imaginary. If you have imaginary solutions, What does that tell you about this graph? No. What does it tell you about 3x squared minus 36x plus 150 if you were to graph it? I'm sorry? If you can't answer my question, you should be graphing it right now. And not one person here seems to be able to answer it. Yes, it's definitely a parabola. What else can you tell me about it? It is not imaginary. There is no such thing as an imaginary parabola. There is, but a parabola is a parabola. That's like saying there's an imaginary car. There are imaginary friends. It is not sideways, but that's a pretty good guess. Definitely not diagonal. What are these? What are these? They're not points. They're values of x. They're specific values. What are they called? They would be the x values of the x-intercepts. Not at all. I didn't say anything about a y-intercept. I said those are the x values of the x-intercepts. Who cares? I've said over and over again, I don't care so much about the y-intercept. But to answer your question, somebody in the class is going to tell you, how do you find the y-intercept for any function in the whole world? Plug in 0 for x. If you really want to know what the y-intercept is, it's 0, 150. Who cares? That's not my question. My question is, what does these two solutions to this equation tell you about the graph of that parabola? Of course it can. Do you have the answer? The parabola does not face down, but now you're getting into things that you should be able to answer. How do I know the parabola does not face down? Because it's a positive edge. That means it's horseshoe up. There are two x-intercepts, and here they are. These are the x-coordinates of the x-intercept. I agree with that. So now, my question is, what does that tell us about this graph?
Where's the vertex?
I don't know. But that would be go a long way to answering my question. What's that? There are, but they're imaginary, so there's no real x-intercept. So what does that tell us about this graph? No real solutions, they're imaginary. What does that tell us about the graph if we have imaginary x-intercepts? We have two imaginary x-intercepts. It's horseshoe up. What does it tell you about the graph? The vertex is, I don't know what that
Above the
means.
x-intercept.
Above the x-axis. In your horseshoe up. Nailed it. Listen to this statement. You could already tell that from this equation.
No, you just picked it out the other way.
What do you know just by looking at this? It's horseshoe up, right? So it's a horseshoe up parabola. Once we get down to here and we found out that the roots are imaginary, we now know that the vertex has to be above the x-axis. The end. So nothing. You could. Do you really want to do that? No. All I want you to do is start to think. What do you know about the graph of this? It's horseshoe up with imaginary x-intercepts. The vertex has to be above the x-axis. It can't be down here, because if it were down here, my vertex or my x-intercepts would be real. That's what I want you to get from this. Now, this process, you can go to different teachers and get it done in different ways, so it's going to be up to you how to handle this. I'm going to show you what I do. Other teachers are going to do it differently. I think that because I have an equation, I'm going to treat it all like I would treat any equation. Okay? So if I'm going to do the same process I did a minute ago, but instead of a 0 over here, I'm going to have y. And because I'm a little bit OCD, I'm going to put the y equals y on the right-hand side. Question? So I'm going to start with 5x squared plus 10x plus 7, and I'm going to make it equal to y like this. And I know that I could leave the y over there, and I can force myself to do it, but I like to do it this way, and you can do it any way you want. Some teachers will teach, don't do anything on the left-hand side. Don't do anything on the left-hand side. I'm just not one of those people. Okay? So, first thing I want to get rid of is 7. So 5x squared plus 10x is equal to y minus 7. Second thing, divide out the a so we have an a that becomes a 1. So each side gets divisible by 5, so I get x squared plus 2x. And over here, I just leave it y minus 7 over 5. Even if you could simplify it a little bit, you know, you could do y over 5, and if it was 5 over 5, you could put a 1. Don't bother, because all those things are going to come back later. Plus blank and plus blank. What goes in the circle off to the left here? Positive 1. What's going to go in the blanks? Also 1. Am I going too fast? I feel like I'm going too fast. Yeah, right here. Half of 2 is 1. And then square that to get 1 and 1. How does the left side factor?
X plus
1 parentheses squared. On the right-hand side, just leave it y minus 7 over 5 plus 1. You might be tempted to clean it up, but all of that stuff has to go in a minute anyway. You've now completed the square. Great job. We need to go back so that it says y equals. Which of these things on the right-hand side do I get rid of first?
1.
The 1. How do I get rid of it? Subtract. So I get x plus 1 squared minus 1. Don't subtract the 1 in the parentheses. You can't. It's being squared. What do I get rid of next? I have y minus 7 over 5. Multiplied by 5. So we're going to have 5 times x plus 1 squared minus 5. Good job. Remember, every term has to be multiplied by 5. This one right here, this right here is the mistake that we'll make. When we multiply both sides by 5, so I'm like this, both sides. BS stands for both sides. I multiply by 5, I multiply by 5. That means I distribute here and here. It's the times 1 is the key. And then you add 7. And when you add 7, you get 5 times x plus 1, quantity squared, plus 2 is equal to y. Y equals 5 times x plus 1 squared plus 2. What's the vertex? Negative 1, 2. What's the vertical stretch? 5. Parent graph? Good job. This is our favorite form. If you're going to graph, this is the form you want to be in. This standard form stuff, I don't want anything to do with this. Even though this isn't so bad, this is pretty, comes out nice and even. I just don't want anything to do with it. Okay? So this process of completing the square, you have options. There are teachers, there are parents, there are brothers or sisters or aunts or uncles or tutors that you may be relying on for your knowledge. And they teach it differently. And I'm fine with that. I was taught the other way to do it when I was in high school and when I was in college. They had us completing the square, everything on one side. You never brought anything over here. So whatever you did, when you plussed something, you then had to minus something. So it became a very complicated process. Works great. If you understand that and that's the way you want to go, I'm fine with it. Anybody have a question here? Anywhere on here? Okay. This one's a solve. They want you to solve it by completing a square. Can't get a break on this. So 5x squared minus 4x plus 2 is equal to 0. Everybody okay with that? Step 1, get it in standard form. Step 2, get rid of the c. And here's where it's going to get challenging.
Could you just move over the 3x, just leave the 2?
You can, but I don't do that. Like I said, I got this OCD thing. This is what I do. Standard form equals 0. Everyone who tries to be smarter than the process, you try to take this shortcut. How much time are you really saving? 0. But what if you do something and you make it careless along the way? It's not worth it for me. What do I do next? Okay? Make sure when it's ugly like this that you are super meticulous. Because step number 3 or 4 says make A equal 1 by dividing everybody by A. It doesn't work. You can't complete the square when A is not a 1. You can only complete it when A is a 1. At least consistently. So you have an ugly value for B now. And fractions are the way to go. Not mixed numbers, just keep them fractions and just work through them. Take half of B. What's half of negative 4 over 5? Negative 2 over 5. That's in the circle. We get a plus blank and a plus blank. When you square the number in the circle, what do we get?
4 or 5.
Nope. 4 over 25. Square the top, square the bottom. Square the top, square the bottom. So we get 4 over 25. Now you look at that left side. If I gave you that on a test and said, say factor this, you're going to look at that and go, what the heck? This is crap. You can't ask us questions like that. But what are we doing? What did we just do right here? What is this?
Square?
Right. Perfect square trinomial. Right here. This bad boy right here is a perfect square trinomial. How come? Because we made it that way. It's not pretty, but that doesn't mean we should ignore it. It's a perfect square trinomial. And it's got a great personality, and it's easy to factor. How do we factor it?
X minus 2.
Wrap it, square it. We love that. Over here, you need common denominators. Negative 2 over 5. Common denominator is going to be negative 10 over 25 plus 4 over 25. And when you combine those, you're going to get negative 6 over 25. X minus 2/5 quantity squared. Nasty, huh? What do we do next? Square root both sides. X minus 2 over 5 equals plus or minus I root 6 over
5.
This is me waiting. You don't want to wait anymore?
Why is 5?
Because it's the square root of negative 6
Oh, it's square root of 25.
and the square root of 25. Square root at the top, square root at the bottom. If you would rather, it's perfectly fine to do the square root of negative 6 over 25. And then do the square root of negative 6 over square root of 25. And then do I root 6 over 5. Don't forget it's all plus or minus. Okay? That's fine. But regardless, you're going to get here eventually. X minus 2 over 5. What do we do now? So x equals 2 over 5 plus or minus I root 6 over 5. Or better, 2 over 5 plus or minus the square root of 6 over 5 times I.
Does that have to be above?
Regardless.
It does not. It's the fraction times I, so that you're in the form of A plus or minus B times I. I will take either of them. The I is to the right. It's not root 6 times I. It's root 6 over 5 times I.
If it's not under the radical, it's still like the factor bars.
Like saying do this, like here.
Yeah.
That's not really where it would go. It really goes here. I mean, technically, our line is down the middle. This fraction is causing to be, the bar would be halfway through the I. Technically.
Saying we figure that we put 0 in for y, that the x index was.
Absolutely. If you take these numbers, 2 over 5 plus root 6 over 5I, and you plug that in for x here, you're going to get a equal statement on both sides. And if you look at this equation right here, you're going to get a 0 on that side and on the left side. So they are the x-intercepts, but they're imaginary. This is a parabola that's horsed you up that's above the x-axis.
Can I just put 2 plus or minus I square root 5 over 5, or 6?
Say it again.
2 plus or minus I square root 6 over 5.
You cannot, because it's not written in the form of a plus bi. If it's a complex number, you have to write a plus or minus bi. Now, the only exception to that is if you have an imaginary, and it's a fraction like this, I mean it's a radical here, not a fraction, then I will accept the I in front of the root 6 just as a method to avoid the I getting pulled underneath. Okay? But this is the best way to write the answer. Okay? I know what you're saying is correct, and I know why you want to do that, but when it's imaginary, we want to make sure we're writing this form. Somebody else? Okay, so when you see problems like this, and you're solving by completing the square, you need to use completing the square. Am I suggesting that there isn't a better way to do this? Am I suggesting that we can't come up with a way to factor this? X plus 4 times x plus 5 is equal to 0. If we're solving, x equals negative 4 and negative 5. That seems like a pretty straightforward way to go, doesn't it? Okay. That's not what we're asking for, though. We're asking you to do completing the square. So we want you to go through the process of actually completing the square. And I know that this and I agree, this is bull. Okay, this is a bunch of crap. You're going to make, because this is what you want me to do. You want me to move that 20 over. You want me to put plus 9 over 2 in a circle. You want me to work with fractions. I hate fractions. And then plus blank, and 81 over 4. I'm having fun. Because that's half a b. 9 divided by 2 is half a b, right? Leave it 9 over 2. We don't want a 4.5. Because it's hard to square 4.5. But 9 over 2 is easy to square. Square the top, square the bottom. How does it factor? X plus 9 over 2 squared equals, this would be negative 80 over 4. When we add it to 81 over 4, we get the lovely and talented 1 over 4. And then we square root both sides, and we get plus or minus 1 over 2. Square root of 1 is 1, square root of 4 is 2, and it's plus or minus. And to solve for x, all I have to do is subtract 9 over 2, and we get that. Negative 9 over 2 plus 1 over 2 is how much?
Negative 8 over 2.
Which is also known as negative 4. And negative 9 over 2 minus 1 over 2 is negative 10 over 2, better known as negative 5. You know what? We got those right there. Are you kidding me? You want me to not do this, to do this? That's like when you need sand for the sandbox, you go to the lake and get rocks and go home and take a hammer and start hammering the rocks until you have sand. Go to Home Depot. They sell it by the bag. Why would you want to take a hammer and hammer rocks to get sand? That's ridiculous.
Or stick the same.
Huh? It gets you jacked, huh? Let me know how that works for you, Jack. Alright. So the completing of the square, in the rest of the notes, you'll see other people's versions of completing the square. Okay? One of the questions you'll see in your homework is, what would C be in order for this to be a perfect square trinomial? You know what they're asking you? They're really asking you, if you have x squared plus 26x, what goes in the blank to complete the square? Half of 26 is 13. When you square it, 169. So C is 169. That's a homework question. What goes in the blank here? What would C equal? 36. Easy, right? What about this one? C would equal? If you're not getting it, raise your hand. I don't understand where you got 36 or 169 or 144. Because we want you to make sure everybody's here. And if you're sitting on your hands, I don't want to look like I'm stupid. You know when you're going to look stupid? Monday during the quiz and Thursday during the test. Ask questions. You want to make sure you're clear on these. Everybody good on the C's?
So your answer should write as C.
Well, the question is what's C to make a perfect square trinomial? So C is whatever it is. What's that?
Will that be a quiz question?
They don't need any work.
Will that be a quiz question?
I don't know. I can't. To be honest with you, I haven't seen the quizzes. But they're done. I just haven't looked at them. Okay. So here's somebody else's notes on completing the square. You're welcome to these also. Here's when A is not a 1. Again, we did this. It's just a different teacher's version. How do you find area of a triangle? 1/2 base times height or base times height over 2. They're asking you to solve for x. And they're telling you the area. Area is 1/2 base times height. 144 equals 1/2 x plus 10 times 2x. See if you can find out what x is. When you have negative 16t squared plus 64t plus 50, we want the height of the object It's maximum. Where does that occur?
Middle.
Yeah, kind of.
Vertex.
At the vertex. How do you find the vertex for this?
Negative b plus. Negative b.
So if I do this, the opposite of 64 over 2 times negative 16, who can tell me what I'm finding?
You're finding
The
X.
X is
It's not, saying it's the x coordinate is not correct for this. It's the t coordinate. So what am I actually finding? What time?
the time it takes
Time it
to
takes
get half the way.
to its highest point.
The time it takes to get to the highest point, it's not going to be halfway. It's not. The only time it could be halfway is if this were a 0. And that means it got launched out of the ground, like right from the ground and went boom. But if you're throwing it,
Yeah.
or in this case, if you stood on top of a 5-story building and threw it, it's not going to be halfway. And you think about this, here's your 50, it goes up and comes down. This is halfway between this and this non-existent point right here. Okay? So the opposite of b over 2a gives you how long? 2. 7. But that's not what they want to know. They don't want to know how long it took,
They want to know how high.
how high it got. Plug her back in. Take the 2, put it in for t. So h of 2 is what you're finding, the height after 2 seconds. So what is the maximum height going to be? How much? I got something different.
114.
Maybe it's different.
I got 114.
I got 114 also.
Oh, cool. Everyone's a winner.
2 squared is 4, times negative 16 is negative 64. 2 times 64 is 128, minus 64 is 64, plus 50 is 114. This is h of 2. H of 2 means plug in a 2 for t. So the answer, h of 2, is equal to 114. So max height is 114 feet. If the question's a word problem, answer in words.